Hi. First of all, I want to thank everyone for your time. My name is Chi Seng. Call me Seng. I've been in Cisco since 2000, but I left 2006, came back 2010, and been doing wireless all along. Today we're going to use the slide as a template for us to discuss what is the latest technology that we have on wireless, mainly basic RRM all the way down to FRA like what we had. And also we're going to discuss mainly the most difficult part of the solution, which is actually the first one, which is how we work with client, wireless client to be exact. Right, so it's mainly site survey. So, all right, so I like to make things interactive, so you do have questions and stuff like that, do ask away. As a company, for some reason, they changed my title as a technical whatever architect. I'm not. I'm an SE. So basically, we've been doing wireless world as well, but used to be called CSE. So and mainly work with some customer, high-touch customer in terms of large deployment. Mainly educational sector. That is the standard implementation that we got is about 2,000 access point, 20,000 client, and hospitals, which is the reverse, probably like about I don't know, like about 400 laptops and cows, computer on wheels, and RFID tags. But then the reverse part of it is that we got thousands of users, which is gas access, which is the reverse. So the funny thing about hospital implementation is there's critical Wi-Fi that is on very little users compared to gas access that's overwhelming the whole RF. So it's totally different use case. And I also have the opportunity to support the outdoor implementation, the difficult part like like mining. Shipyard building, outdoor Wi-Fi access, and now it used to be just shipyard building, and you have CCTVs, wireless, and data usage. But also right now they're moving over to AGV, automated vehicle and stuff like that. And if you imagine Wi-Fi being used as best effort, collision avoidance, and shared spectrum, and they want to run things like that on AGV. So, I mean, well, we have to weigh the risk. So I got a lot of interesting implementations. So I'm not so sure how much of you guys are from different verticals and stuff like that. But yeah, ask away as I present. Right. All right, so what we're going to discuss about is the standard wireless solution that basically we have, and what are the features that we got. I think the number one interesting part that they actually have is spectrum analysis, and it is very critical. We often forgot that we're dealing with RF, and it is very simplified, but I can tell you if RF is broken, we are not in a good position. Right? The first thing that we need to do that at every single site. Every single morning that if you have access of implementation, you have to take a look at the condition of the RF. The RF is like our morning when you wake up on the radio or your TV, you said, what's the weather like? That's exactly what it is. This is about the weather in your network, right? Then we're going to discuss on site survey. Site survey is important, pre-site survey, implementation, layout of your, how high is your access point and stuff like that. And the most critical part that often forgotten by us or even by the end user is, it's the client, right? It's not the infra. The client is the critical problem that we got. The infra IT guys like us usually got we become like the Superman that need to just do everything, make things simple for the client to make it happen, right? So that's the difficult part. So because of that, we will try to share what are the pain points that we got in terms of supporting whatever client we got, right? Hence the site survey. Site survey is ever evolving. Like I said, prior to implementation, during implementation, after that handover, and then operational side. In fact, the painful part of RF or Wi-Fi deployment is operation, the bottom line. It's not after you sign off and then give it over to like the operation team to take off. But it's the ability for you to take a look at what's the condition of RF and the condition of your network right now, and then able to actually, understood where's the problem is, and hopefully predict, what's the next problem going to be. So those are the things that we're going to take a look at. That. I think earlier there's a question regarding about how we're going to take a look in terms of, our basic tool. The other things that we have also is that not all of us have the best tools that we had, right? I mean, if you have Ekahau, MetaGig, and stuff like that, man, awesome. But we can't. So we have to take a look and then listen from the customer point of view, what are the pain points? And then from then look at their tool and look at our controllers and take a look, what are from the basic tool and MacGyver up all the way there to look for the right answer. Right. Then, of course, we're going to talk about basic RRM. Then we're going to move over to FRA. The very cool thing that basically we have, working for Cisco, is that number one, clean air, and the second part that we have is FRA. FRA, we've been talking about it for about now 2 years now. It is somewhat matured, with right now with the code 8.5. So can I have a show of hands who's doing 8.5 right now on the controller code? Thank God. Okay, cool. Right, we're going to do better. It's still kinks, but in terms of FRA, it'll be better. Right? So in a nutshell, the idea that we have right now is that 2.4, we only have 3 independent channels, while 5 gig, we have more channels, and more channels to come, hopefully. All right? And we're going to play more and more on the 5 gig portion. The challenge that we got right now, the traditional AP that we used to have is only 2.4 and 5 gig. Right now, at least, we have 5 gig and an XOR radio. And that XOR radio could act as a client, could act as a sensor, and could serve either client or 2.4 or 5 gig. So the confusing part of what we have on FRA is this. If you could imagine, magically, if we take a look at what is the transmit power control or the channel allocation that we got, right now we're also going to change the role of the access point and then try to put that into a predictable implementation of 2,000 access point, for example. It's a bit hard. So FRA, what we're going to discuss today is how we understand we design it, or how does the tool or the config basically want to do it. So part of the discussion that we're going to have today is understanding that. And then now it's up to us whether we want to enable it automatically or we will study it, then enable it manually, right? So we'll discuss that. There is also on the MetaGig portion, the 28 and 38, because it can do XOR. There's new development in terms of if you are, anybody here using MetaGig? I was worried about that. I don't even have MetaGig, okay? So the slide does show us MetaGig, but the problem that we have is that we don't get even a beta code or a demo code. But one nice thing about MetaGig is like this is the replacement of our Spectrum Expert. So who have Spectrum or used Spectrum Expert before? Okay, good. All right. So that's still valid. So we need that. And I'll explain to you why that thing is important, and I'll show a snapshot of what we actually have on Spectrum Expert. Yeah, reliable Spectrum Expert. All right, so that's what we have. And then last but not least, we'll be discussing a little bit on the high-density deployment and also some of the high-density deployment that I personally do. Right, okay. Right, so end of this session, hopefully you learn. The most important thing that what we have today is that, this slide is for your reference. Majority about this is about me or you giving us feedback and me probably like sharing some of the wounds that we got on the field of deploying on RF and site survey and stuff like that. So, it's more about that. So learning from the field. Right, so evolution-wise, boy. So the bottom line on this is that basically things are doing, chugging along well. First is 2.4B, even pre-standard B, it was all 2.4. Or previously, before that, it was 900 megahertz, right? If you recall, before there was 2.4. And then the standard 2.4 will become B, and then all the way up. So the things that we got right now is that the inflection of devices are moving fast. So like, I mean, you probably heard about AX. Right now we're doing AC Wave 2. Frankly speaking, have anybody actually see Wave 2 laptops or use Wave 2 laptops? See, that's the thing, right? So I mean, the infrastructure is going to be the first one that actually doing all this and stuff like that. So you will probably start to see AX also when we start to see AX devices hitting the road. My gut feeling about this is going to be a handset, right? Because these are the guys that usually churn their base pretty fast, come up with a AX handset, and then you know, it'll kind of come after that. Right, so, but the problem that we got with all this usually are single spatial stream devices, not multiple spatial stream due to battery life, right? So again, our adoption towards this is that, you know, RF is very dynamic, and let me try this. Yeah, and that particular portion here, about 160 megahertz, is very myopic view of how much bandwidth you could get. If you have an office that's about like, you know, like 3 or 4 access point, I think it's fine for you to actually do 160 megahertz. But majority of our deployment that we see, 5 gig is always 40 megahertz. If you want to go beyond that, you could. But if you have, you know, we're pretty sure RF is good, and then your isolation is good, then you should go beyond that, right? But majority of the time, we probably want to reuse the channels, and 40 megahertz is the one that we're going to use. And when we come to AX next time, we will probably just look at that also, right? So what I'm trying to say is that we have limited bandwidth. The channel set that we got and stuff like that not depend on the technology, but depend on the local regulation or even international regulation. If the international body, with all the whole world saying that, you know, we're going to open another band, only then we'll actually have a bigger bandwidth, right? So whatever that, you know, we have to take with a grain of salt in terms of what kind of device is going to come with AX, whether it's single spatial stream, 2 spatial stream, and then whether we're going to burst it out to 100, you know, whatever channels that we got, right? So those are the things that we need to remember. Right, so this is our lineup of products. All are the 1800s. These are the Wave 2's AP. The only difference that basically we have is spatial stream, right? So to cut the story short, majority of our deployment, enterprise deployments are right here. This ones are usually for the branches and for hotspot deployment or service provider deployment. The critical implementation that we have on the 28 and 38, these are the ones that actually can do XOR. Right, radio XOR, meaning basically 5 gig and the XOR radio, which can actually do 2.45 gig or monitor mode. They are of the same code line, which is COS OS. And if you're familiar with troubleshooting and stuff like that, CLIs are totally different. So I really appreciate your patience and enduring this particular migration that we have from iOS to COS OS. They do have a lot of problem in the earlier beginning of the year, right? But one major difference that we have on this is that anybody know why we're moving over from iOS to anybody? Okay, so let me explain. Previously, before that, we are very monolithic in terms of that particular code. We might have 2 core, but we're actually using 1 core. But right now with this code, we can use the multiple core. That's one of the main reasons. One of the other main reasons that we have, if you're familiar with all this range of APs right now, you know that you can run ME, Mobility Express. The main reason behind that, you can run on one CPU on ME, another CPU as an access point. So that's why, right? So there is an advantage to it. The disadvantage to this is that if you could imagine, Cisco has been doing this for like what, since 2000? And from the good old days, we have VxWorks, then we have iOS, then now we have. So between VxWorks and iOS, it takes us about 3 years. And at that time, it was a very small feature. iOS have the good like 10 years plus. And if you try to squeeze that feature of what we have in 10 years and put it into the just 1 or 2 years of COS OS, you're bound to see a lot of unpredictability. So one of those unpredictability that we have is, of course, for anybody familiar with WGB? Wireless group reach? Okay, good. So it's not there yet. So that's one place. It's coming. It will be coming sometime, my understanding. I think there will be beta really soon. The BU will be releasing beta code. So WGB may not be, it doesn't, in an enterprise environment, you don't need it. But the funny thing about it, I was talking over to some of the customers in the hospital. They said they're going to run automated robots to actually send trays and medicine and stuff like that, and they need WGB. So either you run it on WGB, or you can run a Linux device there, or Arduino and stuff like that go Wi-Fi, you know. Yeah, but anyway, so that's the things that we need to remember. So there's good pros and cons about this, right? So yeah. So just remember, when we talk about FRA, it is talking about this particular high-end 28 and 38. It have more spatial stream compared to this one. Well, I mean, spatial stream. This one also have 3 spatial stream on the 50, but it doesn't have 2 FRA. Right, we have a smaller version one, which is, this is like the one that you're actually gonna discuss about the sensor portion. The beginning part of the range, we don't have BLE integrated. You have USB. So next time that you're gonna do some kind of implementation of BLE as a sensor, or BLE as a RFID tag, or I mean a location, like, you know, location beacon, you can insert it through USB. While the newer, cheaper version have inbuilt BLE, right? So those just an extra stuff that's coming. I mean, that's available. Okay, so the same thing again on access point. We have the 1540, the lower end one, and the 1560s and above. The only one that why we put the 1570 here is still iOS based, and this is the big piece of a tank that we're using this majority in the heavy industries. And I use this typically for still WGB because it can work as a WGB, while this guy is a COS-OS, will only be doing WGB first phase, middle of the year, right? Can I ask, any of you are doing outdoor wireless? Okay, good, all right. So I'll spend a little bit of time in terms of caveats. These access points are weather sealed. What I find out from the field is that sometimes we're not as fortunate when it got to the contractors that we got, right? They have done all the right thing, but they didn't tighten the gland, for example. Access point orientation is correct, and then there's a console port and there's Ethernet port. The Ethernet port does have a tightening gland. You need to tighten the gland. But the ones that we actually find out was the gland was not tightened, and the cable you can even feel, you know, you can actually see that. After a while, after about 6 months, there's an accumulation of water vapor inside the access point, and the access point collect water. So those are the things that we need to watch out. So if you are doing outdoor implementation with this access point, get them oriented in terms of how, or contact Cisco, or how to implement this properly with the right tool, also with the right wrench when you actually tighten the external antenna if you are using an external antenna. The tube that we have on external antenna does have a plastic seal. You must get our contractor not to hold the antenna by the barrel, but you hold it at the metal barrel, not the plastic barrel. If you do it on the, even though if you feel it's okay, but actually you're causing some of the areas to be like, the seal portion a bit off, and because of that, water vapor came in too. And then after about 6 months, what you find on that particular antenna, you can shake it and there'll be water in there. Okay, and then your performance, it was okay, but after a while, it's not okay. And then usually when you put this thing, it's like about 20 meters on a pole, and you need a cherry picker to pick it up and stuff like that. Trust me, it's not very fun. The cost of implementation is a bit more, it's definitely more expensive. So outdoor deployment, do look into your weather implementation. Yeah. So it is weather sealed, but if you don't install it properly, you're gonna get a lot of problems. Okay, so remember when also doing the outdoor WGB portion and stuff like that, again, majority of us on this, interestingly, it's not about data connection. It's not about wireless connection. It's mainly about bandwidth. What we actually got in terms of implementation on this is mainly right now for CCTV, surprisingly. Mainly for basically what do you call it, avoidance of accidents and stuff like that. So the IT team have to provide an infrastructure on this, and they put in a high definition CCTV behind our WGB or our mesh, right? So these are the, so it's not just basic connectivity. Right, so moving on. Right, so site survey, out of all the things that we have on site survey is the difficult part that we got is understanding, first of all, what kind of client that we're serving. Right, that's the bottom line. The first thing that we have is that if it's educational sector and stuff like that, it's quite straightforward. It means basically you will have A to Z in terms of client, and you will not have control of OS, you will not have control of brand, you will not have control of even whether you're going to be 2.4 and 5 gig, you know, it's the Wild West. If you're a hospital, it's quite straightforward. Usually they have a dedicated device with dedicated security and stuff like that, and then it'll be like, you know, but the difficult part that they have is, oh, I have IoT device, oh, I have sensors, oh, I have that, and then the next question is that whether you go 2.4, whether you actually authenticate or not. Authentication make a lot of difference because of roaming, very straightforward, right? Because, you know, when you actually create this, you need to take a look at the client. And of course, the good old thing of clients is sticky client. It's a very painful process, right? The sticky client is the challenge that we had, and what we probably learned is even if we could make our cell size so good, but when we deploy it and then they come up with a new client or batch of client, we need to test them up. And then you need to understand how the algorithm works. Thankfully for Apple actually, like, you know, give a documentation. It will only look at minus 70 dB before it looks for a new AP, for example. The cell size range is minus 70 dB. It's predictable. What we're looking for is predictability, so hence we can design the RF. But if you're on the Android world, it's, you know, you need to test them, right? So what are the things that basically we need to actually think of mind in terms of the client portion is a client mix, what type of OS, what kind of device, and then you take a look at your protocol and sizing. I'm based out of Singapore, and majority of our customers is always like, hey, you know, I heard about this AC, you can do 1 point something gig. Can I put like 100 laptops on one AP because I just need 2 gig? And the bottom line about this is you need to do the calculation. Dimensioning and stuff like that is very, very important. Dimensioning for bandwidth, dimensioning for voice are two different things. So we need to actually do that. I mean, there'll be a separate session for that one. I mean, if you do have a question, we can have a discussion. That one is a deeper detail. So what we have on that is that when we know the dimension of the client that you want to implement, then you will know what is the expected bandwidth that you got. From then, you can cover the right cell size. That goes back again to, okay, so who knows RxSOP? Okay, 1, 2. Okay, so I'll discuss on RxSOP later. So when we actually understood in terms of how we can dimension what is the density that we have, then how many APs that we're going to put. The problem that we have with APs is that the cell size for AP could be big, so we need to engineer the RF to do what we call RxSOP and using a directional antenna for us to reuse those channels, both 2.4 and 5 gig. So it is important for us then take a look, okay, so dimension, how many users, and then what is the bandwidth. Then from there, we can take a look what is the typical coverage. Hence, the typical coverage that we actually want to take a look at what is the protocol supported. Whether it's 12 Mbps, whether it's 2.4, 24 Mbps. So those are the minimum that you do. I mean, for but for like, for example, 2.4, you probably should do it at either 12, 16, or 24. You should forget the low data rates. It's still baffling. I think I know why Cisco don't remove the 1 meg and 2 meg and 5.5. You know why? Okay, I'll explain to you why. Exactly. The problem that we have right now is that majority of our customers, not just educational sector. Educational sector is pretty fast in churning. And enterprise is every 2 or 3 years they churn, right? Hospital is the best because they have beacons, they have sensors and stuff like that. They are on still B. So that's the challenge. And then those are, again, a critical customer. Right, so I mean, the IT team have to bow down, and for the right reason, because it depends with healthcare and stuff like that. It's important. That's why one of the reasons why we can't remove that. But not all of us are healthcare customers. So do remember that basically we have to, remove the low, right? Okay. So site survey, right? So I just kind of cut to the change in terms of the things that we have over here. What we're trying to show over here is that RF is not just one level, it's actually multidimensional, and depends on what's your implementation like. It's going to be like old building, new buildings. Old buildings, the colonial buildings are pretty thick, or hotels or convention center, the walls that we got are pretty good. The RF isolation is awesome. RF isolation is awesome, but it means that you have to deploy more access points, or more access points. So like hotel deployment, convention centers are two different, beasts. The other things that we have in terms of the site coverage, we always think in lateral, but it's actually coverage of signal come up across floors too, right? So basically, what we're trying to say over here is that if you have the tools, if you have MetaGeek or you have Ekahau for you to site survey, you'll be able to actually remember that site survey is not just on the same level, but the top and bottom, so you can actually understand what it is. That's one. Now, next portion that basically I want to show later on is that what if you do not have this tool, right? So I'm going to show it over to our lab, right? So just remember. And also the rule of thumb with this is that if you have a leaky signal across your floor, try to actually, like for example, if you put an access point in this particular floor, in this particular room, the next one on the next floor should not be exactly above, but it's, diagonally opposite on different. Those are the standard good practice. Please remember that. The other thing that we had is, yes, IP address segmentation. How many of you are from banking here? No? Okay. So, oh, you are? Okay, I'm sorry. Okay, good. Not sorry, but it's just one of rule of thumb is that typical implementation for banking, usually they say that each different floors have to have different IP addresses due to segmentation. They use IP means for segmentation. But the challenge that we got right now is that, RF does go through walls, and sometimes basically the client you'll be associated to is the one above it, and then your VLAN and stuff like that. So you need to implement IP mobility, right? It's kind of complicated thing, but but just remember that your Wi-Fi will still associate to the one above the wall. All right. So again, a good site survey tool is important. If you don't, now this is the things that we're going to use, right? So I'm going to jump into my. Okay, never mind. I'll just use the. I'll go to that slide first, and then I'll explain. Right, so again, between walls and stuff like that, when you site survey, you want to actually make it into like a mid-range powers, which I'll explain to you where it is in a controller. We're going to do it via CLI or from a browser, right? Again, the challenge that we got right now is that not all of us have the right tools. You can create your own models and stuff like that. Understood that you can actually come up with a floor plan and take a look at models and the floor plans and stuff like that. But again, it all depends on what kind of client device. When I actually site survey, usually what I do is that I always have carried two things, either both an iPhone and an Android, right? You need to have that. Laptop, if you can get it working on an Android and iPhone, laptop will be fine, right? So those are the first thing. And then if you're actually doing a certain vertical application, like an RF gun and stuff like that, you need to site survey with that, period. There's no way around it, right? Because that have a different characteristic, different antennas, different authentication servers and stuff like that. Now, on the wireless portion here, if you take a look at, this is just a GUI representation of the wireless portion, whereby you could take a look at, like, how you actually change that RF, whether you assign it at 2.45 gig or 40 megahertz. Then you can assign the power, right? Now, this power, again, for some of us that doesn't do this often, number 8 meaning the lowest, number 1 meaning the highest, right? Just think of it as resistance. 8 means the most resistant, 1 meaning the highest, right? And 1 meaning no resistance at all. So transit power, if you want to really take a look at the dB transmit power is this, right? 1 is 19 dB, or 8, level 8 is minus 1 dB. So how do we do site surveying, okay? Give me a minute here, so. All right, so this is an existing controller that is on our demo lab, right? So if I click clients, these are the clients that we got, for example, and let's say assuming that I have one particular client that I want to troubleshoot, or basically not troubleshoot, because case all are N and G. So I change the filter, then look for protocol. I'll look for example, the AC version or AC clients. So I'll select, for example, one particular one, workstation maybe. Okay, right. So from this alone, if you don't have MetaGig and stuff like that, or Ekahau, you could actually see that what is the current transmit rate that they have. The most important part that you should see is this one here. Now you could see that this is not very good, even though it's connecting at 5 gig. It is connecting at the corner of the network, SNR of 12, RSSI minus 77. So if you do not have access to the tools, you can at least see from an access point of view what is the transmit client of this. All right, this is the first thing that you need to see, right? So then if you are troubleshooting and if you want to really know where this client is, I'll take this MAC address and I'll telnet or SSH over to this connection. The demo god, come on, please. Yes. Uh-oh. Yeah, that's the one. Yeah. Okay, so I take that MAC address and then show client detail. I hope everybody at the back could see. Can you see it well? Yeah, thank you. So a couple of things. Okay, of course, this is the same thing. It's actually said it is in slot 1, meaning it's 5 gig. Wireless LAN ID, that SSID and stuff like that, connected, IP address, blah, blah, blah. This is the standard part that we have, right? QoS level, current rate, the beacon rate is, you can see that basically it's not very good because of the distance. So you can see this at 18, right? And wait for it, there, right? You get this, right? So I mean, when you do an actual site survey, you do a telnet to your controller or SSH to your controller, you capture this, and then you can actually put like no pages or config pages disable so that you can actually capture it as you walk, right? That's one. And the next thing that you should see is this. So in this infrastructure, I have multiple APs. Now, if you could see from here, from this point of view, the multiple APs tell me that those APs seeing this client at what particular signal. And you will know whether it's a sticky client or not if any one of these AP is showing like 60 dB, right? while these guys, if you take a look at it, it's all are pretty far. So in this particular laptop is really, really far. It is really sitting on the rim of the network, right? So these are the things that you should see, right? Right now, when do you know there's a sticky client? Again, if it's associated at a lower signal, and then the rest of this access point showing it. Okay, so this is a very good example of non-sticky client. So I mean, it's just good, right? But those are the things that you can see, right? Again, we have multiple APs here, so I'll explain to you onto the browser. So, right, so we have all these APs. What we did is when it show client detail, you'll see that client from the perspective of the rest of this AP, not only from the associated AP. So that's really helped a lot. Okay, so use this tool is one of the nice things. The next thing that you have is, of course, if you're using Apple, you could take a look. I'm sorry, I can't zoom that one portion. But yeah, you can actually take a look at the, what is your signal strength in this case. If you're using Apple, you could see what is your RSSI and what's your noise and what's your connected rate and stuff like that, right? Those are the things that you should see. So iPhones, you don't see this very well, but Android have a lot of tools that you could use, and you can use that as a means for you to site survey. Because there's two things that you need to remember, right? Infrastructure point of view, seeing the client, or the client point of view, seeing the infrastructure, right? Different antenna gain, different transmit power make an effect, right? Any question on this particular one? Yes, sir.
Do you do comparison between the two as well, because they will be depending on the device that you use?
Yes, you always use the lowest common denominator. My rule of thumb is this: when you're doing the coverage, you take a look whether it's going to be whatever device that you had, and then you find out which is the worst of the device, and you find out, number one, the most important thing, the one that you can really control is RSSI signal, which is the cutoff point of your boundary, which is about, my rule of thumb is try to get minus 67 of the rule of the boundary, and then basically that's what you could do. You can't control the noise, seriously. From creating that boundary of minus 67, then you will take a look at the SNR. But SNR is only at that time of the day, and 2 months later will be different. But at least your boundary of 67 will be there. So the next question is that, okay, 67 from whose point of view? Access point of view or client point of view? Right, so that one's, for my end, I'll always look at the access point of view minus 67. And then not only looking at the minus 67, but also I take a look at the rates of transmission. Right, so if you have a very good rate and stuff like that, it's all depend on SNR, by the way, right? Then basically, those are the things that you can note. There is no guarantee. The only guarantee that you can create or give to whoever is owning the infrastructure is that RSSI value. You can't guarantee the noise, you can't guarantee the bandwidth and stuff like that. It's all based on SNR. So yeah, right. So the lowest common denominator and minus 67. Okay. Question? No? Good. All right, so moving on with the slide. So again, basically those are the things. When you're doing, oops, sorry, put it on slide mode. Right, so the mandatories and stuff like that are also important, because when you show information like this, so show AV config and stuff like that, you're able to see the transmit power and also the mandatory rates. Right, these are the things that you need to take a look at. All right, duty cycle. So every time when we actually troubleshoot an RF network, I always take a look at the first thing that I see is channel utilization, the duty cycle. So if you, okay, so some deployment we might have clean air, or like an AP 3500, 2700, 2600. But some APs that you have maybe older, which is the 1042s, 1142s, that doesn't have clean air. The bottom line about this is that I want to take a look at how busy is your RF. So the first thing that you should see is channel utilization, right? If you don't have that, no, you will always have that. But if you want to take a look at the real spectrum, you need to have a clean air, right? So the bottom line about RF is listen before you talk. So it actually take a look at the media. If the media is busy, it will not transmit. Right, so that's the bottom line. Okay, so channel utilization, what it is. So without going further, I'm just going to take a look directly at the controller. The first thing that we do is this. Okay. Just go to monitor, access point. For example, you take a look at the summary, and then you go to this is 2.4, this is the 5 gig, this is the XOR. So I'm going to take a look at the worst one, usually it's 2.4. Then you just click this button here, then you click detail, for example. You can select any one of them. Usually you select ones that actually have a profile of fail. I got one which is fail interference profile here. So let's take a look at that, click detail. I always like to see the text view. Now, from this text view, you can tell us that this particular access point, for example, it is slot 0, G, and this is not doing the right thing. It didn't tell us the channel. Okay, I'll have to come back on that one. But what we're trying to show is this, is channel utilization. So with this, from this point of view, this access point have 13% of channel utilization. This is transmit and receive. So whether you're using clean air or non-clean air, you will always be able to see this. So what is this? This is how busy is your Wi-Fi. I mean, you can modulate or demodulate the signal. And you can see that the attached client is only 1 and you have 13%. And the nice thing that we have on this is that you can tell us that that client connected at 2.4 is connected from an infrastructure or access point of view at -60 as an SNR of 40 dB, which is pretty good, right? So this one is pretty good, right? And the next one that you should see is also the surrounding APU in terms of RRM, right? So what is the next APU available and what are the channels? Oh gosh, this one didn't show the channel. This is not right. Let's take a look at another one. Right, the first thing that you need to always see is the channel utilization. Yeah, it's up. Channel utilization 32. So what is the value of channel utilization that you want to take a look in terms of normal 2.4? Normally, you should see somewhere about the 20s. Busy one is 40s. You should sometimes see a burst of 70 to 80, but never constant. But once you see a constant 40, a constant 70 or 80s, that's a real problem that you had, right? So the usual remedy that you have is to take a look at how many SSID that you're broadcasting in that particular radio, and what is the beacon rate. And if you can't control it that way, then you have to move on to RxSOP. So those are the things. That's the only tools that you have. But once you go to RxSOP, you really, really need to do site survey, okay? So those are the things, right? So the first thing they need to do is look at the channel utilization, and that's that. So let's take a look at the 5 gig one. Same thing. As you know, standard 5 gig will always have a lower channel utilization, by right, but let's take a look. Okay, it tells us channel 64, 2%. Oh, there's no client, that's not fun. Let's take a look at monitor, and then look at client. Change filter. This is to take a look at who are connected at 5 gig, and from then basically we actually take a look at the AC. And okay, so we got staff room. All right, let's take a look at the staff room 5 gig. There we go. All right, so from here, it is a channel 100. It got 2% with 9 client attached. This is good, right? And the nice thing that you have on this is the client distribution, right? Again, PI will show you this, historic and stuff like that. But if you want to actually take a snap point of view of what it is, you can use this straight away, right, on the controller itself. Right, so you got 2 of the device at minus 68, 6 of the device at minus 60, and then you can, from here alone, you can take a look at the demographic of your coverage. It is very good, right? Again, you don't want, I mean, you should not go beyond anything above minus 76 in terms of signal. And from SNR point of view, your rule of thumb, try to get it above 20 dB. Right? If you got your SNR at 20 dB, you're awesome. Okay, but it doesn't mean that you're good, right? But at least on the RF side, you're doing the right thing. The next portion of it is to take a look at whether you're transmitting at highest possible rates. That's where the clean air portion comes in later and stuff like that. Do remember that, right? So again, this is the first thing that you see. Okay, so what is the rule of thumb of looking at problem? So if you got a call from a customer saying that you got an issue somewhere, you just find out which area or region. If you have PI, great. You can go to PI page and then take a look at the channel utilization of 2.4 gig and understand the condition of the RF, right? Then you can take a look at your user demographic and stuff like that. Question? Okay. All right. So right. So, okay, we talked about this already just now, channelization. Sorry. Okay, so this is a spectrum expert view of things. You probably see a lot of this because in order for you to do this right now, you need to have MetaGig. But if you're not, you can use the spectrum expert. The spectrum expert view is that allows you to take a look at the, for example, the channel utilization or usage of that, and then you can see an actual high definition of interferences, non-Wi-Fi, right? So things like this will be, this is Wi-Fi traffic with the proper delineation of channels, and then if you have something sticking out of it like that, that shows there's interference, for example. This slide is to tell you SNR is the most important part, right? But the problem that we have right now is that we can't control noise. So we can only control your signal strength, RSSI, right? So this indicates why SNR, the best case scenario, you try to actually make it at 20 dB. The difference, if your SNR is less than 20 dB and stuff like that, it's very hard for you to differentiate between signal and noise. And because of that, your transmission speed will fail at a higher speed, and because of that, the channel utilization usually pick up, right? Because usually what happens is that you will have to retransmit and stuff like that. So SNR is the critical part. Okay. Right. If you use Spectrum Expert View, you'll be able to see per channel, in this case, like Uni 1, Uni 2, Uni 3, and you can see the slopes, right? The valleys and slope. If you can see all that, that's the typical very good implementation. And the nice thing about this is that you can start to see whether there's any interference. Things like this is good. Things like that is definitely bad. You cannot see the difference between the peak and the trough, right? As you can see that here, you can actually get a 3 dB or 33 dB drop between noise and signal, right? If you can only see a little, then that's not good. If you could see this dotted here, things like that, that usually are Bluetooth, right? So this or, yeah. So those are the things that we can see on spectrum. Now, if you do bandwidth testing and you want to know whether you are doing 20 megahertz, 40 megahertz, these are the things that you also need to see, right? For example, if let's say, this is channel 36, by the way. If channel 36 is your, what do you call it, what do you call your primary channel, then your, when you do 40 megahertz, usually is the next channels will be your carrier channel, right? So basically, you want to know why you're not doing 40 megahertz. It's maybe because this particular channel is being used or not, right? When you're using Spectrum Expert, when you do bandwidth testing, if you expect to have 40 megahertz, what you should see is that these two bar, both of them will be on at the same time. That's what I'm trying to say. So you need, sometime you should look at the Spectrum Expert or you have to use this as like a monitor mode or spectrum X mode for you to take a look at this particular condition when you're troubleshooting, right? So those are the things that we could have. Right, just one more example of, right, interference. Okay, so we move on to a network discovery protocol, the basic fundamental that basically we have in terms of how our infrastructure access point arrange the channel, right? So very straightforward. The bottom line about this is that the access point will transmit management frame. And the management frame depends on your typical threshold that you created, which is about minus 80 dB. That value you can change, right? Depending on how dense you want to implement it. And it always goes at the maximum transit power allowed and at the mandatory rate that you actually, the minimum mandatory rate that you create. For example, you can do a mandatory default about 6 Mbps for 5 gig, right? Or you can even do 24, depending on how dense is your implementation. From there, the infrastructure will be able to detect what is the transit power that it needs to set and what is the, what do you call it, the cell size or the channels that basically we need to do. So two processes that we have. One is TPC, and the other one is DCA, dynamic channel allocation. So I'll go straight over to the deployment, which is over here on the controller side. So wireless, right? On the RRM, on the 5 gig one, you have TPC and DCA. And these are the two ones that basically we have. The first thing that you always have to remember when you do DCA is how often do you change your channel? You don't want to make this channel change too often, but you don't want it to make it too slow, right? Tag, if you open tag, usually we'll always recommend more than 1 hour or about 6 hours, 4 hours, depending. You don't want to do it too often, right? The more that, the dynamic, every time you change channels, the client got disassociated. Just remember that, okay? Then you can create your own flavors of deployment, like whether you want to avoid foreign AP interference or not. You want to take a look at your AP load before you change channel, things like that, right? Again, this is the portion whereby you do a good rule of thumb of your deployment. If you're 5 gig, my recommendation is always go 40 megahertz if you can, unless you're doing high density deployment. That one you probably do 20 megahertz. And the next portion is the DCA channels. Rule of thumb of DCA channels, there's the Uni 1s and Uni 3s, and there's the in-between with this Uni 2 extended, which is the trickiest part, whereby there's radar usage, right? DCA, right? So that areas is always the challenging part, whereby you cannot properly probe until if there's no radar. And the client doesn't automatically always look for access points. So if you're going to do this particular channel's adoption well, you should enable 802.11k and V. Why? Because that will assist your client when they're actually moving over to those DFS channels. Okay, try to do that. Otherwise, your adoption, or your the device that connect over to it will be, if you take a look at demographic, majority of it is always at Uni 1 and Uni 3, but there's not many people connected over to the mid channel. All right, so try to make full use of that if you can. Okay, question? That's on the DCA part. Okay, good. And then on the TPC portion. Okay. Usually I keep this as default, and it is always about 10 minutes in terms of deployment and stuff like that. There's always detecting the 3 closest strong AP at minus 70. Again, this particular power threshold default is minus 70, but depends again on your density deployment, right? You can put it at minus 60 and stuff like that. It is very dense, or if it's very far away or far apart and stuff like that, you should do differently. But again, the idea of TPC is so that the access point can hear each other and then decrease the cell size. It does not increase, all right? So it always, this particular process of TPC is to find out what is the most optimum smallest cell before it interfere one another? That's the portion, okay? Right? Any question? Yes.
Do these F-7, do these numbers change with voice?
Shouldn't. Yeah, it shouldn't. Basically, this one is basically a AP channel spacing. It's an infrastructure channel spacing. When you actually do a coverage hole, then that's the particular portion that you had. But usually, good rule of thumb, I would try to make things simple if I can. You know, there's a lot of tabs and knobs over here. I usually go with minus 67, right? That's your usual coverage. Okay. Any other questions? Okay, good. All right, so those are the basic TCP, okay, and then the configuration that we have in general, right? The scan interval, how long that basically it actually takes to actually transmit the hello packet to the rest of the access point, and the frequency. So there was, okay, so this particular value has been constant throughout until just quite recently when they start to do 8.0 and stuff like that, they changed this. The main reason why they changed this is because we got more and more denser deployment on 5 gig and stuff like that. And what engineering did was have the ability for you to tweak it faster in terms of conversion. Tweaking it faster means that basically the access point will be able to calculate and then get the thing. And it's pretty dynamic, that value. The challenge that we got on this is that when you do it faster and you keep on changing and you're deploying like about 1,000 of access points that are able to hear one another, your reference point of that particular used to be, you know, a particular channel keep on changing. In a nutshell, when it comes to the latest code of 8.5 and stuff like that, this value used to be 5, and 5 is very not good, to cut the story short, right? Because what actually happened, you start to see erratic change on the RF and stuff like that. That's happened with 8.2, 8.3, and 8.1, and 8.0 and stuff like that. We start to reimpose back the value of 20, right? So try not to change this if you could, unless AS come in and stuff like that. So that's one of the things that basically we have. Neighbor timeout factor is important because it will try to make that particular coverage stable. Frankly speaking, if it's up to me, I try not to make too much changes on the RF, right? Because once you make a lot of changes on the RF too often, client got disconnected, right? The majority time of our deployment usually is that if you're lucky, you are in buildings or floors that you can maintain, which means that basically, you know, you can control the RF and stuff like that, and hence you don't change it as often. But if you're deploying it in a branch deployment, whereby like, you know, you got 1 or 2 APs and 100 of branch, yeah, you probably need to do this differently. Because at that particular point of time, there'll be other access points around it that interfere you, right? So it's 2 different implementations. So 2 different philosophies, so we need to take a look at 2 different approach. If you're deploying at campus or building-wise and stuff like that, try to make this constant. Try to make it, by average, I'll say, you know, remember the DCA portion, try to make it even 4 hours, right? The dynamic channel, the allocation of your channel, try to make this 2 or 4 hours, right? And then the TPC, you can make it dynamic because you can make it every 10 minutes because it's actually about like, you know, shrinking the cell size and stuff like that. It's quite okay, right? Okay. What you don't want to do is your, what do you call it, is changing the channel. Changing the transit power is okay. Now, the next pain point that we have comes to this, the TPC portion. This is a real-life implementation and problem that we got. There was an earlier question regarding about what happened with AX migration. I have a similar issues whereby we have a migration from N to AC wave 1 and wave 2, and even between 2 different APs, meaning you have a wave 1 1700 and you have a wave 2 1800. There are 2 different radio and 2 different receiving sensitivity. We find out that some segment, if you do mix and match a different AP model or different speed and stuff like that, you have a very weird kind of sticky client that stick only this to this AP and stuff like that. So you try to segment those AP if you could. Meaning, if you're going to do migration, migrate them per batch of a certain area. That's rule number one. The second rule that we have is to, once you change and done that, you should take a look in terms of the client coverage. One thing we find out is that whatever that we do on RRM is from an infrastructure point of view in terms of coverage. We will try to shrink the cell size properly and stuff like that, but frankly speaking, in the real environment, the client may not see it that way. So the one that often change is not this value, but this value over here. This is critical. So this value is related to that particular transit power over cell size. And that depends on your client type. So this will make whether the client roam faster or roam often or not roam often, right? So try to play around with this value in terms of your cell size. Because you can take a look from an infrastructure point of view of coverage, but sometimes if the client doesn't behave properly and then become very sticky, you need to play around with this value, okay? So that value, again, requires you to just walk about and find out what is a typical client roaming. So what will be the usual value that they have? Again, I usually are quite conservative. I usually put this in the middle. This is not my deployment, but basically, depending on how big it is and stuff like that, I usually, maximum power is about 10, and then 30, and then the minimum one, you try to make it not too minimum, right? It all depends on your deployment. You need to properly, you just need to play this one. So that's what we learned. Okay. Right. So, again, how much are we in time? Man, okay, it's almost an hour. Right, so these are the standard thing that basically we have. Neighbor discovery protocol is actually done in the back end. The retention time, again, as you can see, what we're trying to show, last time used to be 5. Right now, if you got the latest code and stuff like that, this value will actually, by default, will be 20, right? Now, once this is done, and your TPC is done, and your channel set is correct, and stuff like that, then you go to FRA. Okay, so what is FRA? So the 28 and 38 have dedicated 5 gig radio and an XO radio. This XO radio is a similar one that you actually have those modules that you actually insert on the 3600 AP and 3700 AP, right? It's an XO radio. It can do 2.4 or 5 gig per radio. So the good thing that we actually have on this in terms of vision was the ability for it to actually serve 2.4 and 5 gig, or you can do 5 gig and 5 gig, or you can make it as a sensor, or you can make it as a monitor mode, right? So that's what we have, all right? So, but then using that network discovery protocol, we're going to create an algorithm. So the story that we have on FRA is this. The philosophy that we're trying to do right now is this. That second XO radio is designed so that basically you can reuse the channel, meaning you can do 2 5 gig. So what actually happened is that when you enable FRA, the access point will take a look at the coverage factor of your 2.4. So what it does is just look for coverage factor of 2.4. If there's enough coverage for that particular one AP for 2.4, that radio, the XO radio, will be actually called a candidate for it to change. That candidate will depend whether you want to do client serving, or you want to do monitor, or you want to do sensor. So how does it decide, right? The challenge that we got in FRA is this. It is relatively new. If you want to do this automatically, you should understood that, okay, the rule of thumb that I have is this. You have to enable FRA, but don't do it automatic if you could, right? Do it manual. Then you can take a look at the coverage factor on the coverage factor, then you can decide, that particular AP makes sense for it to become a client serving 5 gig or a monitor 5 gig, right? So it can have multiple different function. It can do a client-like mode, it can be sensor mode, and we'll discuss this in this particular portion. Right? So, if you debug, okay, for example, I'm just going to go straight away to the slide. It's easier. To the actual demo. I have another controller right here. I might need to log in. So, in terms of wireless, I have a couple of access points here. You can have 1552, as you can see that. There's 3800, 2800. There's a a Wave 1 3700 with hyperlocation, and then the 1815W, for example, right? I could take a look in terms of their third radio, for example. What is the XOR radio, forgive me. So you can see that these are the XOR capable radio and their capability, right? Whether they are client serving 2.4, whether they are client serving 5 gig, right? This is client serving while this is monitor. So what we have with RRM is that if you make it auto, you can automatically assign it for you. Now, for us at IT, frankly speaking, it's a bit too brave. Because, the problem that we have right now is that, okay, so one good thing about 28 and 38 is that the capability for you to do multiple 5 gig micro and macro cell, right? But the challenge that we got right now is that sometimes if you leave it over to the algorithm, it'll decide for you, and sometimes things may not perform as what you want, right? So unless you're pretty sure and stuff like that, you could enable this. But right now, in this particular code that we have, is pretty stable in terms of deciding what it's supposed to do. The point of this particular slide that we have right now today is to guide you through what it's trying to do, and I'll explain it to you, right? So that's the thing. So going back again, the first time when this AP came up, it will take a look at the, overlapping 2.4. If there's way too much overlapping, one of that particular radio will be a candidate for it to become 5 gig serving, or if there's too many 5 gig, it'll become a monitor. So if you see what we have over here, this particular one is doing client serving, and it's actually transmitting power at the lowest possible power. That's why you see a star, which is basically assigned by RRM, right? And this particular one, right? This one is doing monitor, because basically it feels that there's enough channel at 5 gig, and it does not convert it, and it actually becomes a monitor client automatically. When it's actually doing monitoring, it's actually doing RRM, it's doing wireless IPS, or it can even doing location-based services. This is, it's multiple lab that we actually had. So automatically it does that for you, okay? So if you want to take a look why they did it, you take a look at click monitor, and then you go access point, then you see this dual band radio here. You click this, and tells you what is the coverage overlap, right? Now, we at Cisco are pretty conservative in terms of FRA, so majority of the implementation that we have, we want to actually have 100% overlap. Now, when you decided that a particular candidate radio change over, or become a candidate for you to change as a 5 gig client serving or monitor or sensors, when that thing change, meaning basically become a role to client serve, it automatically covers all that value, become unavailable. What's gonna happen, this is in the future, is probably you will probably see this value as a bracket value. What is used to be the value that you had. When you see a bracket value, it indicates that basically what was seen previously before it makes the change. right? There's a lot of confusion. People said that, why is it unavailable? Is it a bug? What actually happened is that when it changed from a candidate to something that it changed the role to, client serving or sensors and stuff like that, it doesn't retain the previous value. That's what I'm trying to say. Okay. So again, usually the rule of thumb that we have on this is that if you want to make this manual, that will be the easiest one. I mean, for you to actually understand why, right? So you can go dual band, for example, on the radio itself, and I could change this, right? Oh, I actually put it on manual. So let's happen if I actually do auto, and let's try that. Okay, and basically it'll come back. Right, so when you do FRA, it will actually do the most important thing that we actually have on this is you will start to see this value here. It's coming up, but it actually will actually change the coverage overlap factor, right? All right, so that's one. So if you do it by CLI, which you could, right? You can show advanced FRA. You can tell you that FRA is enabled and the time interval that it changed. It's not like RRM where you can actually change every 15 minutes and stuff like that. You don't want to change this very often, okay? So that's very dangerous because, you're changing the role. You got disassociated client and stuff like that. So the minimum value that we have of FRA change is 1 hour, okay? Right, so you can see the APs, you can see the slot, and this is the coverage, what do you call it, overlap factor value, which is say none, which is a bug. So, right. Okay, the deployment of this requires you every time that when you actually have RRM and FRA, you have to point it to the same. What do you call it, RM reader, right? So how do you see the RM reader? Majority of you probably will have multiple controllers, correct? So sometimes you got confused which controller is actually the leader. So the quickest way for you to do it is go to controller. You can actually assign this. The nice thing that we actually have with the latest code, you can assign this, right? You can take a look at the RF grouping, right? So it will indicate who's the group leader. When you have multiple controllers, this is the most important part that you actually have in terms of like assigning channel bandwidth, whether 20 megahertz or 40 megahertz. Please put them on the same one. If not, then basically you have a very mixed result. The same thing with FRA. You have to point to 1. The rule of thumb that we have in this is that if you have 3 controllers or 3 cluster of controllers, go to a controller that have least access point and least client, because that will actually optimize the memory in terms of channel assignment, TPC, and also FRA, right? That's the rule of thumb that basically we have. Choose always to the one that is not so busy in terms of controllers. Right? So if you can assign that, that will be the best. If you don't, the question, yes?
Can you actually take a control that doesn't have any APs?
You could.
Effectively, like you have a maintenance control there.
Yes.
Which doesn't do any APs or any.
Yes, you could. Just put them on the same RF group. Right? So those are the things. That's a luxury that we don't have, but sometimes if you have that, that's awesome. Right? So, yeah. You should, okay? So before you troubleshoot any kind of like, why is my DCA is not working? Why is the channel is skewy? Why are certain, like for example, very quick implementation that we have, not even looking at FRA, is that if I take a look at this access point implementation, right, this new controller, the other controller, if I take a look at the 5 gig distribution, right now, in some of your deployment that you have thousands of access points, you sometimes start to see, hey, you know, my DCA setup is always actually 40, but then sometimes you see sometimes are 20, sometimes are 40, sometimes are 80. Why is it so? So the first thing you need to see is that whether all of these controllers point to the same RF leader. That's the number one that you need to do, right? So that the TPC and DCA, even FRA will work properly. That's what you need to see, right? Try to make it predictive, so try to assign it if you can, manually, right? And then after that, if they all are pointing to the same ones, then maybe, because you know usually there's other team that managing the network, then you should take a look at your AP grouping, right? So for example, RF profile, you can create your own RF profile, right? From the RF profile, you can assign different channels and whatever is the bandwidth, my understanding. Yeah, there, over here. So if that AP group is in a particular RF profile, it'll follow this profile. It have to. If it doesn't, it's a bug, right? So, but again, so this is the thing. So look at, always pointed to the same RF leader, and then after that, then look at your RF profile, right? For some of you that are going to do high density deployment, these are the portion that basically play around with this. Question, yes?
Does this work for centralized controller, like when you do Flex Connect?
Flex Connect centralized, it will work fine. So whether you're doing it for, yeah, Flex Connect and local.
Like if I have one WLC for separate location for the data center.
Yeah.
And the one I'm doing an active backup
Uh-huh.
on it. And so with your suggestion of pointing with the DC clients, I'm not using the other controller
Yeah.
for serving the clients. Can I point it as an RF group leader?
You could for the RF group leader, but if you have like exactly like what your implementation is that you have two different data centers, but let's say assuming you want to be predictive and you know in terms of, okay, so in terms of RF leader, you should point to the one that is least busy. That's number one. But the reason why you create these two DC of controllers is basically there's a possibility for the controller to fail over. The first thing that you need to remember when you do controller failover is AP grouping. The two controllers at two different DCs should have the same AP group. And you should have the same mapping of APs goes to which AP group, and with this AP group, which RF group that you create on that. So the bottom line on this is that, I mean, if you're designing in two different sites and stuff like that, first rule of thumb, AP groups have to be similar to what your deployment, irregardless who is your RF leader, right? Okay, that's one. The second rule of thumb is that when you go to that AP group, you have to assign them with the proper RF group so that it's predictive when you have a failover, touch wood. If you have a failover, then the AP will join the right AP group with the right VLANs and the right SSID and the right RF profile. Okay? Got it? Okay. Sidetrack a bit there. All right. Okay, so RF leader, very important. So let's take a look again. Yeah, it's counting down, 41 minutes. Okay, we got time, don't worry. So what we're trying to show in this particular slide is this. If you're doing FRA before 8.5, don't. So do it after 8.5. Okay, so 8.5 is actually it's more stable, but even when you're doing it with 8.5, okay, so I'm very confident with our RRM, TPC, DCA. It's good, but FRA is changing of an AP whereby sometimes you can. Let's take a look at this. We have 3 APs in this room. If we make this all 5 gig capable, I have actually 6 AP that's serving you guys at 5 gig. But what happened if FRA kick in and decided, no, I want to actually make it like, I'll just do 5 gig and the rest are monitored? Then we are in big trouble. In terms of capacity planning, we are in big trouble, right? Because if something were to go wrong and stuff like that happened and there's a conference here and everybody is full and everybody's like streaming and everybody's submitting a request and stuff like that, you will not have enough capacity. So the rule of thumb is that we can create whatever model that Cisco can provide. But sometime in real life, you probably want to take a look at how the system look at it, and then you decide manually. So my rule of thumb of FRA is very straightforward. Number one, you should enable it. Number two, only when you know what is the coverage type and the typical implementation, then you do it auto. But if you have a critical application that you need to run in terms of bandwidth and SLA, what you should do is that you have to do it manually, right? So which are the case that I have? The deployment whereby you have a lot of access point for educational sector, classrooms. You could enable FRA. Because what actually I did for the classrooms and stuff like that, I know as a fact, one access point can take 40 students easy. So if I have an extra access point around it that do 5 gig client serving or 5 gig or 2.4 monitoring or even as a sensor, I don't really care. In terms of capacity, I'm good, right? But if you have a convention center, then you should not even try to do this automatically. Okay, so it's about risk. It's about deployment and about predictability of troubleshooting, right? So that's the thing. So if you have plenty of access point to implement for schools and stuff like that, yeah, right? So my rule of thumb usually in terms of design is take a look at what is the worst capacity that you get in one particular floor plan. If you can have it like with those existing AP, non-FRA or non-auto FRA, you'll be fine, okay? So again, right, this is the old way of doing it, whereby what happened is that when there's a lot of 2.4 overlap, that XO radio will become either a client or monitor mode, right? The challenge that basically we have on this is that once it's actually stuck to that particular monitor mode, it will not do anything other than like, doing monitor and then 2.4. That's it. You do not have the flexibility for it to go like monitor, serving 2.4, or serving 5 gig, right? So hence, we come up with a new one, which is giving you a better algorithm for you to decide. Now, that particular algorithm and stuff like that is decided internally within the controller. So again, like I said, even our deplementation-wise is that please go with 8.5, right? So how this behavior look like and stuff like that. I mean, if you are familiar and good with your floor plan and stuff like that, like for example, that APs are in the rim of your network, whether it should do FRA or not, it all depends on your decision, right? FI for the client session. Okay, so let me explain the new 8.5 implementation that we have. For example, this is after FRA is done, whereby you have 3 access points here. These are 28 and 3800 series APs. And they find out that, when the AP come up, they said, oh, you got overlap, awesome 2.4 overlap. So this AP goes to DCA and find out, hey, I can't assign any more 5 gig because all your 5 gig is already used. So I'm going to make this AP to become monitor. The same thing over here. It detected that basically we got a channel overlap and the XO radio said, hey, you got your 5 gig well covered, so I'm going to make this into a monitor. Right? While this one basically said, oh, I'm going to go 2.4 serving. Right? So this is the typical environment that we had. Remember, FRA only changed once every 1 hour. Right? So that's the fastest way. So in this kind of deployment, for example, there's a rearrangement of grouping of users, and then basically most of them are moved over there. But if your meeting is only going to last you for 30 minutes, FRA not going to change. So just be warned, right? So what actually happened is that when you start to see a lot of this particular client coming in, and then you start to see that basically the client serving side on the on FRA will start to say, oh my God, this guy have a utilization of more or certain threshold. Now you can define those thresholds. And if that threshold is reached, it automatically converts this monitor mode to become 5 gig and 5 gig. Right? So it actually creates more capacity. There will be overlap, but at least basically in that particular area, it'll actually do that. Question, yes? 1 hour. That's the problem. I can't make it, we can't make it faster, right? I mean, yeah. So the thing that basically we have on this is about optimization. So worst case environment is that even though if this doesn't change, the capacity of this 5 gig is good enough for you to cover for those particular capacity. So that's the thing. So this is more like a good to have and it changed. Remember, this only happened 1 hour at any one time. So it means that for this to happen, it makes sense for you to actually have like a add move of change that happen like, that's more than 1 or 2 hours kind of thing. Change of furniture, change of role of a room, or things like that, right? So if you want to have things which is fast, or dedicated implementation, make it fixed, right? So remember, FRA, okay, I'll just explain. So FRA, again, the fastest way of actually doing this is you cannot go beyond, below 1 hour. Anyway, you don't want to if you can, right? So, right, this is things that you can automate, but we need to actually take a look at what's the role and stuff like that, right?
What's the difference with the sensitivity values there?
Okay, so that's the portion, that's the next slide, right? So what is the sensitive value that basically we have on this? Right, so basically when it actually happened like that, and then it'll change. After that, when it actually moved back, okay, so this is the portion that basically we had. So the interval is 1 hour. This is the value of basically for the client select 40% and 5%, for example, this particular example that you can create. It means that if the first radio of 5 gig detected that you have more than utilization of 40%, it straight automatically enable that monitor radio become client serving, right? And then when it detects that, it'll stay like that until the combined client reset, the combined 5 gig and 5 gig, the combined that went down to like another, in this case, value will be 5. Now that value depends on to you. I would usually do this, my rule of thumb is that if one AP is good enough for me to serve the whole client, I think, another one, if I do it monitor, maybe, it's more like about good to have, right? So what I probably put value over here is like 40, while this one probably will be like, I don't know, when it actually dropped down to like about 60 or something, because it's aggregate value, yeah.
It looks like at the moment that FRA is a global setting. Is there any roadmap to do it as an AP group?
Yes, that are the things that we had asked for. Yeah, that it will be very nice to have. I agree with you. Exactly, right. So there's a lot of things. I think the nice thing that basically we have on terms of redeployment of coverage is the AP group and RF, RF profile, and tying that particular portion in. When we actually have RRM tying to the DCA and stuff like that, the next thing that we have is FRA. Those are the things that probably we're going to try to make the list. Thank you for the feedback. Yeah. Right. So, okay. So these are the value that you can actually put. Again, it's dynamic. Again, it's up to you. What will be the value? The idea that we have is that if the first radio go beyond 40%, it automatically changes the second radio to become client serving. The only time that it moves back again to monitor mode is when the overall module one, the 2.5 gig overall drop down to 5%, drop down from the total of what is actually 5%. It then actually go back to 5 gig serving client and monitor mode. Right? That's what we're trying to say. Okay. All right, so that's when actually when the users are coming and stuff like that. Now, the next interesting part that we actually have is the assurance. So some of you went over to the world of solutions, right? Have you seen the assurance portion that you actually have over there? It's very good. You should go there and take a look. Okay, so Cisco is a bit slow on this. I'll be frank with you why we're a bit slow on this. Because we try to have the whole integration of both wired wireless and also the back end that basically we had. So on the assurance part, we have been planning this for quite a long while, right? Part of the interesting thing that we have, if you take a look at our APs on the 8.6 that I'm running right now on the controllers, if I go to wireless, the dual band radio, I can do assignment, right, of FRA. So right now it's actually both of them. No, that's not good. You see that? That is not right. Both of them at 64. That is not right. But anyway, let's debug that later. Okay, anyway. So in this particular portion, on your XO radio, you can do manual. You can do client serving at 2.4 or 5 gig. For example, if I just apply this, right, and I can actually make it 5 gig, right?
Is it only an 8.16 or 8.4?
I think it's 8.5. No, we on default, I'm using this to actually do another POC. So I'm using 8.6 for other things. But yeah, you're doing it, you should be, yeah, you will be able to do 8.5, right? Yes, question. Yeah. And there's other things at the back end. If you guys free, I'll show you. Yeah.
Sir, you had a scenario where, like, you had all the clients moving to one area, which is complicated right now. By default, like, if FRA is automatic, then it's like within 1 hour. But if you know that this is happening, can you go manual and change?
Of course, yes.
So it's not restricted by the 1 hour limit.
You can do it manually, meaning basically every time that you know, you could change that. Problem is that basically you got 1,000 and then you will not know which room and stuff, which event and stuff, right? So, of course, so the good rule of thumb is that design effectively in such a way that if one APs are there, it's enough for the capacity. So whatever extra resource that you have, you can reuse it for client serving. That's the whole idea behind it. Okay, but if you have, as a known fact, is a conference and convention center, you always over deploy in terms of radio. Right, so definitely you're going to do more 5 gig, as you will see later on, right? You'll do more 5 gig, and you definitely need the sensors and the monitors dedicated, and I'll explain why, right? So there's the next phase. So one nice thing about this is that the role assignment that we have, right? You can do client serving 5 gig, client serving 2.4, or you can do monitor. Monitor will be actually good for you to do like location-based services or wireless IPS, right? And the only additional that basically we have on the latest is the sensor. You cannot change it to a sensor until you get connected over to sensor backend, right? So let's look at it this way. I don't have a sensor right now, so if I click apply, it will say that WSA must be enabled before, yeah, right. So basically a complaint. Right, so you need to have a back-end portion, DNAC, for it to be enabled, then it'll actually act as a sensor. It's awesome. All right, now let me explain why it's awesome. So again, we are really moving to the sensor network, whereby our access point now is become a sensor. I mean, sensor is a very sexy word. Actually, it's always been a sensor, right? We do SNMP trap, we do, those are sensors. It's just that we do it by SNMP, and it's like about 20 over years technology. What we do different this time is we detect what we have, and then we do streaming telemetry, period. That's it. When we're going to do N-bar and stuff, it probably is also the same thing. The idea that we have, we try to create our infrastructure to become more lean and able to extract that information and stream it to you, right? Stream it over to your cloud server or to your DNAC for take a look at what it is. So What it used to be like, a trap of Ethernet port down and stuff like, we just stream that information as a bit information of when you parse that information over, right? So that's what we have. So when you move over to the sensor portion, so, right, okay, so I'll go back over to the slide, right? Oh, sorry, I need to be on a presentation mode. Right, so do remember the 28 and 38 can be a role base, meaning the radio can change. But once you go to the 1800s, is the whole AP become either a sensor or a monitor or client serving. Okay, just remember that. So that's the differentiation, right? So these are the first thing that we have, right? So information like association, authentication, key exchange, IP address, these are the streaming telemetry that we had. So when maybe some of the Cisco guys that you actually contacted in Australia or anywhere like me, when we have the DNAC actually assurance testing, release in about 2 weeks' time, will actually go into more detail, right? You remember when we actually do a debug of a client, you can actually every time there's a problem, we debug. What we did with engineering is that imagine that if you take the key important points of each different state machine of an association, each different state machine of an authentication, and state machine of a DHCP, we put that into one bit that we stream. So we create a very scalable way for us to inform as a sensor what's going on, unlike what we had last time. Last time, if there's a problem, we need to debug a client, and then that particular story is gone because nobody knows, there was a problem 3 hours ago in that particular location. I don't even know what's the MAC address, for example. Right now, with the streaming telemetry that we have, with the sensor, or with this, you could. So what actually happened without even a sensor, an access point right now with 8.6, I need to come back to 8.6, but what happened is that an AP state or controller will take a look at this state and start streaming upstream. So it doesn't need to be just a sensor doing this. Whatever client that's connect, I'll know what state and I'll stream those state to you. That's why when you actually take a look at the GUI that you have downstairs, you can see a green line GUI. That particular green line GUI is a summarization of a value. In that case, will be what we call onboarding. If you click the onboarding portion, then it'll tell you which part it failed. That's why you will know that you can play the historical part of it. It'll tell you at which part of a state machine it failed, and tell you which part, which is a DHCP portion, whether it's .1x take a long time, whether it was key exchange that is not accepted, and then we have to re-authenticate. Those information are there. So that's how we can actually do this at scale. You know how we do it at PI, right? PI is a dinosaur with SNMP trap and stuff like that. So we have to take a look at the traps and stuff like that. Right now over here, we just stream those information. It's a streaming of a state machine. That's what it is, in a nutshell. Okay? So it's pretty nice. So it's about time for us to have this. On top of that, after onboarding, you can actually do network tests. So the device itself will actually do simulated tests in terms of DNS radius. My understanding, this one is not available just yet, but it will be coming, right? Okay, so FRA calculate redundancy targets. So what it's actually trying to say is this, right? When FRA decided that actually it's going to go to sensor, there is a client priority, which is like, it acting as a client at -67, or you can actually, the bottom line about this, there's 5 different type of coverage, right? Of different sensors, right? So whether you want to do client priority, client preferred, balance, and sensor preference, and then sensor priority, right? So sensor priority means basically you want to dedicate that sensor only acting as a sensor. It will transmit as loud as it could, goes over to the next, What we're trying to show is here in this kind of deployment. If these are all 2800s and 3800s, and if any of the, so let's say, for example, when FRA automatically designed this, he'll say that this one's going to be a sensor and that one going to be a sensor. If this were to decide to actually do what we call what do you call it, client priority, or we said basically like that particular coverage size, what you will have is that you will have this sensor only able to cover this AP, and this AP. Will be able to probe those APs, right? We'll be able to actually associate or try to reassociate to this AP. So there is no means for these sensors to monitor or to actually probe test these particular 3 APs, right? So that's what we're trying to say. There's a different stage of that particular if you leave it to RM to manage, right? So in this kind of case whereby the sensor's coverage is only up to here and you have like some kind of a blank spot where there's no sensor, there's a portion whereby you're going to put in the smaller sensor, which is the 1810, right? The smaller version of that particular sensor, right? Yeah, so that's what we're trying to show, right? So that's where you actually, the sweet spot for you to put that thing in, okay? Yeah. So, I mean, the question of that, basically, the portable landmark that you have, you can see that, this is pretty nice. You can USB power it. You can even put a power plug and stuff like that. Yeah. The question being is whether practically for you to actually have an AP, put it in the plug somewhere as a sensor, maybe for troubleshooting, maybe yes, but permanently, I don't know. I don't like the idea that there's a network device that somebody can unplug and then take home. Not the IT team, right? So it can go missing and stuff like that. So I mean, yeah. Anyway, right. So this is one of the things that we had on this. It can actually act as a sensor. It can also be a small access point, right? And also have a Bluetooth. Right. So these are the priorities of the sensors. You have client priority at -67, and sensor priority is basically you maximize that particular sensor capability to detect. Okay. I can't demo this right now because we don't have a network on that one. Okay, so for who over here have high density deployment? Can I have show of hand? Okay, good. What is the maybe you, what is the typical high density that you have, like in terms of users? About 100, 200, 500? 200 plus. Anybody higher than 200 plus? What do you have? Okay. Thousands. Yes. That will be a different use case. Okay, I'll explain to that. So the standard that basically when you come to about 200 plus and stuff, those are the typical one that we have high density for office environment, or for small meeting rooms or bigger meeting rooms and stuff like that. That's a very good rule of thumb for us to have that. If you have an implementation like that, then you will need to actually do, find out what is the typical client that we have in the office, and then take a look at the bandwidth utilization, and you have then plan the APs accordingly. Majority of the time, you will not do an auto FRA. You will do a manual FRA. And if you have something above it, then you make that particular AP auto. That will be fine. Convention center, totally different beast. I design site, which is about 1,000 implementation, 2,000 user implementation. It requires us to do RF engineering, like what we have over here, a different kind of antenna also. You need to do a site survey and find out what is the RXSOP, then you manually assign it, right? You probably most likely not gonna do RRM on that particular convention center, definitely. Right, so this leads to the point of you're aware in the TPC, we have TPC 1 and TPC version 2. What we're trying to show over here is that the intent that we have on TPC version 2 was in order for us to actually have a better capability in a high density environment. What we find out was it was not as effective what we had. So what we did was we actually make the TPC version 1 more effective, closer to TPC version 2. In a nutshell, we try to say that do not enable TPC version 2 unless AS is involved. If you want to enhance the TPC version 1 in high density mode for 5 gig, just enable this channel aware on TPC version 1, right? This one. This is available 8.5. Okay, this is what we're trying to point in this particular site on the new code. Right, this is typical one for you to enhance better 5 gigahertz, what do you call it, transmit power. Right, we only encourage you to use 8.5, do not use 8.4. unless text specify or tell you to. Okay, so, all right. Okay, next stage. So any of you have, so none of you have MetaGig, do you? Any of you have MetaGig? No? Oh, you do have, awesome. You should try this, please, and tell us. The nice thing that basically that we actually have on MetaGig is this. You can run them simultaneously to actually have, one is the dedicated 5 gig, the other one is the XOR. Whether you want to do an XOR as a client serving, or XOR as a monitor, or XOR as a 2.4 or 5 gig, you can tweak that particular thing through MetaGig software, right? So you can actually have MetaGig control the APs for you to take a look at the different condition of your RF, right? And you can replay them. It is very, very nice, okay? It makes life easy, definitely, okay? So this is what we have with MetaGig. As you can see, you can actually run 5 gig and you can run XOR, right? Both client serving and 5 gig serving, so it actually can take a look. And you can manually assign those through MetaGig again to select what are the things that you have, right? Similar view, right? And you can control, okay? Right, so you do 5 gig and 5 gig. Have any of you seen the benchmark testing that we do 5 gig and 5 gig micro and macro cell? It's pretty good. So you have a good channel utilization from the same AP. And again, majority of our high density deployment, they are doing this. They are doing this. So one single Ethernet cable for you to do 2 radio or 5 gig from the same physical hardware. It's super awesome, right? And of course, automatically, when you even do manual assignment, it always offset 100 megahertz channel for you. In terms of like, if you want to manually assign those channels, it'll force you always to go over, and then the smaller cell will always have the smallest transmit power, while the big one, then you can actually play. The other ones you can't change, right? But one nice thing about MetaGig is that you then could see, in terms of channel distribution, in terms of usage, how much it goes over to your micro cell, how much over to go over macro cell. It's very nice. Okay, that's where the MetaGig comes in. So if you don't have MetaGig, you'll be like me, which is this. So there's caveat in it. The good, cool thing about this is that it still works. So 6 years ago, this thing is still very useful for me to troubleshoot. This will prove you very, very useful in terms of troubleshooting anything non-Wi-Fi. It's a lifesaver. When I did benchmark testing, for example, right, when I actually do like 2 channel against, whether it's you using the whole channels or the whole both band channel, you can actually see whether you're doing 40 megahertz or 20 megahertz. You can actually see this. That's very good. But the only thing that it doesn't have is this. You remember that, okay, so just now on the MetaGig, right? You can assign the MetaGig client to actually do, that's not the right slide, forgive me. You could do this, and you can capture this at the same time. With Spectrum Expert, you can dedicate that one on 5 gig and another one on 2.4 period. You cannot do, I wish that we could. If we could, then, but then too bad. I mean, next time when you troubleshoot, you have to dedicate one access point as Spectrum Expert, and then you can just have the same thing. Right? But again, you will not have a live view of what it is and stuff. Only MetaGig could do this. So, yeah, those are the nice things that basically we have. All right, so, right, don't ditch out your Spectrum Expert. It's still very useful. This has long time coming, so we have what we call Spectrum Intelligence. It's a cheaper version of Spectrum Analyzer. It's like a Me Too for us. So this one just more educational. Let me explain. So we have a controller with wireless access point right here. And you can see that the 1850, and that, for example, you have 1815. If I click this, right, I can enable what do you call it, spectrum, I mean, intelligence on this. But when you actually take a look at spectrum intelligence and stuff like that, you will start to see things like this in clean air. Oh, not much on the 5 gig, but let me take a look at the interferences on 2.4. Ooh, that's not right. What's going on? It's not good. Hold on. I'm not showing it. Let me see, hold on. Hey, hello. Enabled. What did we do there? I need to troubleshoot this. I'm not seeing this baby here. Huh. I'm sorry, I have a negative demo here. So by right, you should see this. Forgive me. I'll take a look at it later. When you enable spectrum intelligence, right? What you see is that this one, you will have anything that actually have spectrum intelligence, you will have a $sign at the back. It is not clean air, but at least it actually tells you that, it detects something similar, something like a Bluetooth or something like, so it just basically map up to certain values and stuff like that. This will indicate what you can see is only up to the controller level in terms of, the information. It will not also tell you the severity. So it'll tell you that there's something over there, but it doesn't tell you, which is very important, remember, right? This particular severity value is that if you go anything beyond 20%, you're screwed, right? So if majority part of the Bluetooth that you see and stuff like that is actually just a standard, or 1 or 2%. I'll show you a live one, right? So majority of the time, when we troubleshoot client network, we always take a look at interference, right? Interference devices and stuff like that. Oh, you're kidding me. Something is not right here. Oh, no, okay, anyway. Right, so this is what you will probably see most of the time, or BLE and stuff like that, but the severity is, usually is that, right? When you have things like this, it's actually just a nuisance, but it will not disrupt your network. But if you have something like that, and it's always constant, then you need to take a look at why is it, right? So anything beyond 20% is not good. So this is the 2.41. This is the 5 gig ones, which we don't have. Okay. So going back, if you have a critical network and stuff like that, please use clean air APs. If you just need best effort and stuff like that, then you can still have that as a indication. But it will not tell you the severity level, and also will not tell you in terms of CMX, location of that interferer and stuff like that. It will not give you that particular thing. So you definitely get what you pay for in terms of deployment access point, right? So so please use, if you can, you do have a critical implementation that you need to be RF aware. Please use clean air, right? Compared to what we have. This is clean air. This is the spectrum. Yeah, not good. Right? Cannot see differentiation and stuff like that. This is how you enable the spectrum intelligence, call it. Again, we promise this to the market, we deliver it, but frankly speaking, yeah, it just gives you an indication, but doesn't give you severity, which is, from my point of view, is not very good. Okay, so for some, anybody use this particular tool? What do you call it? Okay, so when you do PI and stuff like that, you take a look at the coverage of your RF, right? You can take a look at in terms of your RF coverage. This is PI 3.2. And you can take a look at in terms of like, it have a different GUI. It gives you in terms of, you know, your neighbor information of the distance of the RF and stuff like that, which is very good, right? This is always very useful for you to take a look whether RF working or not. This is one way for us to do it, map by map, floor by floor, okay? So, or you can use WLCCA, which is Javier and Cisco put in, which is free. But who have used this tool previously before? Awesome, right? Sadly, it's only run on Windows, so please make full use of it. You can show run with all the AP information. It'll extract it. It actually tells you what's the condition of your RF of your implementation. And these are the things that you should see when you use this tool. This is a very good tool for you to surgically, or clinically take a look at the condition of your RF, right? So let's take a look at one particular one, whereby you have a channel distribution for 2.4 portion. This is a number of APs and stuff like that. How much is your demographic, right? Channel 1, 6, and 11. You can see that in this particular implementation, things are 10 over to move over to channel 1, right? But again, 2.4 is not very critical, but majority part of it will be on your 5 gig. You can take a look whether your RM workings or not and stuff like that by looking at the demographic of this particular channel distribution, right? It is very helpful, right, for you to take a look. The other thing that basically we have on this is the config analyzer in terms of TPC, right? So this is the power level. If you can see on this is that on the 2.4 portion, it's about, you can take a look at this is quite dense still. Okay, no, not really very dense. You see that some of the deployment is the second minimum transmit power, meaning that there is some implementation which is quite dense, but there are some areas, about 15% of the RF of your coverage, maybe it could be at the rim, 50% of it is at the rim, therefore the transmit power is the biggest. So that's what you're trying to indicate. Now, the good rule of thumb for you to take a look at this is that if you want to know whether you're deploying it good or not, right? For example, if you have majority of your demographic of your 2.4 are transmitting at 1 and 2, you are actually in trouble. It means that your APs are very sparse. Either that or RRM is broken, right? So these are the things that you need to see. Okay, so those are the things that you need to take a look. The same thing with your 5 gigahertz, right? Same thing. So those are the things that I just want to point out how you actually should read this easily. Okay, so look at the TPC portion, very important. And it also tells us about the analytic of the client because it does take a look at your client point. Remember, when we actually go to the controller and take a look at the client demographic, from the client demographic, we can actually, you know how we actually got this? It's a summarization of what we have over here. It's a snapshot, actually. So this is more like a snapshot, right? Remember when we're actually doing this? When we go monitor, we go like if I select one of them, I usually like to take a look at the text view because it's easier for me, right? This is what we actually see, right? This is a summary of one particular client. But when you extract it into this particular tool, you will see it in the overall picture of the whole network, right? Right? Now, this indicates that basically, for example, 82% for 2.4 is at -76, and about 66% at -68, which is a sweet spot, right? Also, the same thing over here. You can take a look at, like, 90% at -76. Okay, so this is not too dense an implementation, for example, right? This is the RSSI. Okay, same thing. Okay, so going back again, what will be the value that you want? In terms of real nice, if you could, you can have, I would say, about 82% of this at least minus 70, for example, right? Then you have a very tight, neat, good coverage. Okay, this one, yeah, but anyway, you know, as long as you're happy. The other things that basically we have is this, right? SNR. Now that just now was an indication of how you put your APs, the one that you can control, the RSSI, the one that you can site survey and determine the distance from AP to AP, right? But this one you can't control because it have a noise involvement, and then in this particular capture that we got, that we got basically only, okay, so let's take a look. I said 20%, so a summarization of basically anything below 20%, those are like about what, about, yeah, 20% of it still under 20 SNR. I mean, for 2.4, maybe that's okay, but let's look at 5 gig. Yeah, anyway, so the sweet spot that we have is always try to go 20 megahertz 20 dB in terms of SNR. Okay, so at least you get a pictorial view of what it is. So from here also you can take a look in terms of like some of the RF profiles and stuff like that you create, whether you actually do manual assignment or not manual assignment. They can tell us what kind of deployment that this one have, whether it's basically a convention center. Majority of the convention center is always manual, by the way, yeah, because we want a predictive implementation. Okay. And of course, channel utilization, 2.4 and 5 gig, or distribution of your channel utilization. So this tools is done by Javier. So again, please kindly download. It's free. And I can, frankly speaking, majority of the time, when tech got the show tag from you guys, you know what they did? They take that show tag and then put it into this particular thing and take a look at what's the condition of the RF. And from there, they could understood what needs to be done and stuff like that. It's like a general temperature, like reading, or heart pressure reading and stuff like that of a network. That's what usually tech does. Okay.
Is that related to the project we used to get and the newer kind of SD code, the main screen as an analyzer?
Yeah, yeah.
Is that related to that as well?
Yeah, yeah. This is basically a tool that you can download.
Put in the GUI on actually in the main login screen, one of the takes an analyzer of the current line on. Is that related to that?
There's one, yes. I have yet to test it, whether it's basically still doing that particular thing. I know what you meant. Quite a while back, we actually put that in, where you have to actually upload your show tag and stuff like that, right? Okay, all right. But again, this tool that we have is an actual EXE tool that you can run on your own time and stuff like that. You can take your own snapshot. Right, so what we have and all that, and basically we actually put it in that particular GUI that we have with the latest. So if you have the latest GUI, or which is like 8.3 or 8.2 and above, you can actually make full use of it. Or the best practices, okay, got it. So if I click home, for example, all right, so the first thing that I usually see on this is usually take a look at the access point. No, not that. Actually, I need to actually take a look at the access point performance. The first thing that I usually see is this. I always want to go home directly over to here. This is the summarization of that particular tool that Javier actually created. So this is, like, for example, the implementation that we have on 5 gig. What's the channel utilization like of each of the 5 different APs? Of course, when you have hundreds and thousands of APs, probably you actually have a summarization of, you know, some of the top ones. But if you take a look at the 2.4 ones, this is what we actually have at 2.4, for example. And you can take a look at the client demographic or client performance. the typical one that we had. This is things that I usually see. This will give us a sweet spot of what is the majority coverage. So you have only one client that is at the rim. The rest of it are pretty happy, right? In terms of connection rate, they are also quite happy. And signal quality-wise, only one of them are at that particular area. So what I'm trying to say is that this particular home GUI, I'm pretty sorry that we cannot put this on PI, right? So I mean, it's pretty sad, but at least basically you have it over in your, on your Spartan GUI that basically have. These are the two first things that you should see: channel utilization and signal strength distribution for your client. And it's available at 8.2 onwards. You should actually just take a look at this. And from then, basically, you can troubleshoot, like, for example, this guy, who is this guy? You can click. Then, you can take a look who is the client and stuff like that. Okay? So it's a summarization of that particular information. All right. I'm actually over time, so I'm just going to go over to the last important portion, which actually have high-density deployment. Okay, so we discussed that. Okay, so have any of you seen this particular Berlin implementation? Okay, no. Okay, so I just take a snapshot of what the rest of the European folks are covered and sampled, right? This is a particular high-density deployment for pure 5 gig. The rule of thumb of high-density deployment, number one, always set aside 5 gig SSID as itself and 2.4 as 2.4. Never use, the word never is, okay, so I would say that if you can, have a dedicated SSID for 5 gig and a dedicated SSID for 2.4. Let the user decide, right? Don't try to actually have a single SSID for both 2.45. That's the first rule of thumb. Then you eliminate all the issue, or should I do band select, should I do load balancing and stuff like that. You'll actually have that. First rule of thumb. Second rule of thumb is basically capacity planning. Take a look at how big is your capacity in terms of how many users, and from then you calculate backwards in terms of what's the quote-unquote guaranteed bandwidth that you want to implement, and then you just multiply by the number of APs. From that number of APs, then you try to then, you create the cell size as acute as we can. Once you deploy that and you actually create the RX SOP or the signal strength and stuff like that, majority of the time you can actually, there's a cookie cutter implementation, right, whereby there's a cookie cutter implementation that you can actually do. Right, whereby you can create, right? So for example, this particular one, for example, the 5 gig one. Other than the channels that we have, right, of course you have to play with the particular supported or non-supported mandatory rates and stuff like that. That's very important, right? The channel size, right? Whether if it's going to be 5 gig high density, please do 20 megahertz, don't use 40, so you can reuse the channel much more better. And also you can play around in terms of, you even have high-speed ROM and stuff like that. No, I didn't know. So you can actually select the channels properly, right? So you can play with this. On the high density, we have predetermined high, medium, low. But if you have AS or like an actual person that actually knows what's going, you can actually do this by manual assignment. The smallest coverage is minus 60, if I'm not mistaken, minus 65. I can't remember, right? But this is razor sharp, meaning, sometimes when you're connected to an AP, sometimes you could be at, like for this thing, it's like it could be minus 34 or minus 30 and minus 40. There's a lot of variation or change. So whatever value that we have, we try to make it simplified. That's why we actually put it like high, medium, low. But if you know what you're doing, you know what's this coverage over here. Say, let's say if I measure it as minus because you can only do it minus 65. So he said that, this is like minus 65. You probably will not put it exactly at minus 65. You put like about 3 or 4 dB extra for variation. That's rule number one. Then you create that particular cell coverage. Then you actually create that particular zoning that you have. The next rule of that, after that, is that when you're doing that particular implementation, you always do it in the room whereby it's empty. And sometimes if you let TPC manage this, meaning transmit power control manage it, the access point will be like hearing each other so loudly, they're actually gonna, shrink the cell size. But what you don't know is that basically when we have whole room of people, we have a whole bag of water that's absorbing this, right? So hence, you probably most of the time, when you see a high density deployment, what we do is that they will actually mark it to a certain transmit power closer to the higher side. Right, so it eliminates all that particular, so that you can get the signal to noise ratio kind of thing better, right? So those are the things. Anyway, going back to the slide. So what they did was this. They did a lot of this and doing deployment with the certain Gilaroo, the high big antenna gain that we have. And they have 7.5 times overuse of the 5 gig, right? And this is how you're going to read this slide. Sorry. Should put in the presentation mode. This is the trend that we have. So this is a mix of N and AC. If you take a look at this, it's built in 2016. The mix of AC was 31, majority of it is of N. And this is 2017. You can see within 1 year, there's a big jump of AC client. Right, so you probably will see this particular slide 2 years later when we do actually AX. You probably will see this. But what the rest of the European team that do Cisco Live that is trying to show is this. There's a marked increase in delta in terms of adoption. And you can see the mix of used to be just 50% of 5 gig, now moving over to 92% of 5 gig. And the traffic volume, same size room, more AP with better RxSOP and good RF design. Again, you take a look at APs, it's like used to be 600, they put twice as much, right? Twice as much AP. And you can even get an aggregate bandwidth of close to 2 times. So with proper RF engineering, with RxSOP, you actually can really squeeze more from the bandwidth. So the good thing about this is also the justification why we want to make users go over to higher speed possible. Why? The higher speed we go, the more efficiency that we get. For more efficiency, then basically we can actually transmit more data, right? Okay, so I can see that I'm way over time, right? So yeah, so that's the thing. So I can actually take a look at the 5 gigahertz performance of that. It is good. Anyway, so there's a lot of other learning portion that you can actually go to, again, about RRM and how we actually do FRA and stuff like that. So do visit those sites. All right, thank you. If some of you want to stay back and ask questions, please go ahead. Thank you very much.